Okay, sometimes you come across an SAT problem where the question asks you not just to find X, but to find some weird expression that includes X. And if you understand what they're doing when they ask that, it sometimes leads you to a quicker solution. So I want to show you one like that, and actually a couple like that, but we'll start with this one. Okay, you're given what looks like a system of equations, and you're asked to find not X, but 2X plus 3Y. Now, I'm going to briefly take a look at how you would do this the school way. If you are, a pretty confident algebra student, you might look at this and say, oh, I see right away, I've been given two different equations for X and Y. I can set up a system and solve them. And then once I know what X and Y are, I'll be able to plug in here and do it. And okay, I'm going to start the process. We'll probably lose interest in this in a bit, but one way to do this would be to notice, if we double the second equation, we'd still have the first equation is 5x plus 2y equals 8. And if you double the second equation, you'd have 6x minus 2y equals 14. You add them and the y's drop out, you get 11x equals 22. Oh, how nice. At least it's not a terrible number. Divide and get x equals 2. Okay, but you're still not done. Now you got to substitute back into one of the equations to find y. All right, let me keep doing that. I'll use the first equation. 5 times 2 plus 2y equals 8. Gonna have some negative numbers here. This is 10 plus 2y equals 8. Oh, eventually you'll notice, or you'll solve to get y equals -1. And now I'm done. Oh, wait, no, I'm not done. I still have to do what they wanted me to do. I've got to do 2x, so that's 2 times 2 plus 3y, so that's 3 times -1. And when you work all this out, you get 1. All right. Now, that wasn't terrible, but it actually could have been worse. They could have chosen numbers that made us encounter ugly fractions along the way. And yet I want to say, what else could we have done with this? And I think you're going to be, well, happy and annoyed at the same time. Someone who's been warned about this kind of thing looks at this and says, hey, wait a minute. If they wanted me to if they wanted to see if I could solve systems of equations, they would have just asked me to find X or Y. There has to be a reason that they asked for this weird thing, 2x plus 3y. Why would they want that? I wonder if there's some way that what they're asking for is easily related to what they gave me. Well, let's take a look at this. If you rewrite this as if you were getting ready to do it the school way, and then you just ask yourself, is there anything easier? Could I just add them? Well, if you add them, you get 8x and 1y. That's not what we want. Hey, what if I just subtract them? You would never do that in school. There'd be no point because it doesn't make any of the variables drop out. But if you just try it, look what you get. You get 2x, and then 2 minus -1 is 3y. Oh, how about that? 2x plus 8 minus 7 is 1. If this were a school problem, this would be completely useless information. But it's not a school problem. It's an SAT problem, and it's not useless information. It's exactly the answer to the question that we wanted. One step silliness. It's really just, it's not fair that there's such an easy way to do it for the kid who knows that it's time to look for one. And the thing that tells us that it's time to look is that they didn't just ask for X, they asked for some expression involving X. Okay, now, if you're wondering, is this a thing they still do on the SAT? Well, here's one from an old SAT, a recent one. I forget which of the recent practice tests I took this from. This might be from test 10. This is question 19 in the non-calculator section. It's supposed to be a hard question, but anybody who's been coached to look for this kind of thing says, hey, wait a minute. They're looking for 5x plus 5y. Maybe there's an easy way to get it. Oh, holy cow, look what happens if you just add them. That's literally all you had to do. 5x plus 5y is 2,500. Now you might think, oh, this only shows up once in a while. And that's true, but on this particular test, the very next question was this one. Now, you could do this by solving the system u plus t equals 5 and u minus t equals 5. Get the values of u and t, and then plug them in here and calculate. And it would work, but you're going to find that it's a little bit annoying because, first of all, when you do u plus t equals 5 and u minus t equals 2, you could add them to get 2u equals 7. So u is 3.5, and then t comes out to be 1.5. But now look at this. Now you've got to, well, subtracting them is easy, but first you got to, here you have to square them and then subtract them. And this is in the non-calculator section. That's actually more arithmetic than a non-calculator problem really requires. What they're rewarding you for here is not doing this, but instead noticing, hey, wait a minute. They didn't ask us to find u. They didn't ask us to find t. They asked us for this strange expression involving u and t. What if there's some way to do this more easily from the information that they've given us? Well, I will say this. If you walk into the SAT only knowing one thing about factoring, know how to factor the difference of two squares. So when you see two squares, so when you see u squared minus t squared, know that that's u plus t times u minus t. Now, how does that make it easier? Well, wait a minute, they gave us all these things. U minus t is 2, u plus t is 5, u minus t is 2. Multiply 2 times 5 times 2 and get your answer. It's 20 and you're done. But again, this only works out if you notice that, ooh, they didn't ask me for the variable, they asked me for some combination involving the variable. Quick look at maybe one or two more. Okay, this one was on the easier side, but it's still a good use of the trick. You could solve 2x plus 8 equals 16. You could solve for x and then plug in to get what x plus 4 is, and that's fine. But even here, notice they asked for x plus 4, and they gave us 2x plus 8, not 2x plus 7, not 2x plus 9, 2x plus 8. They were hoping that some of you would notice, hey, that's exactly double what we're asking you for. In other words, divide everything in half here, and you get x plus 4 equals 8, and you're done in one step. Not that the other way was terribly long either, but that's pretty quick. Okay, one more, and then I'll call it a little mini video. Look at this one. They give us this equation with lots of variables in it, a's, x's, and b's. And they ask us to solve for, oh, look at the expression, ax plus b. I wonder, is there any way to get this easily from what they gave us? Well, I could add 6 to both sides. I think I'll do that first. I get 9ax plus 9b equals 27. And now let's stop. That's almost what we're supposed to be finding. They asked for ax plus b. This is 9ax plus 9b. They were hoping you would discover or notice that if you just divide everything through by 9, you'll get ax plus b. You still won't know what a is or x is or b is, but they didn't ask for that. They asked for ax plus b. And literally you divide both sides by 9 and you get 3. However, let's say you didn't think of that. I just want to do a quick throwback here. This is another chance to use making up numbers for the variables. Let's say I didn't think of dividing everything by 3. I could just try to make up numbers that make this true. For example, if I let a equal 2, 9 times 2 is 18, and I don't want this to get too big, so I'll let x equal 1. I need 9 more, so I'll let b equal 1. There, I just made up a set of numbers that works. 9 times 2 times 1 plus 9 is 27. Now I use those numbers to answer their question. When they asked what's ax plus b, I plug in our numbers and I do 2 times 1 plus 1. And of course, I also get 3, which is exactly what you got if you did it the quicker way. Okay, going back to the very first one though, because the other thing about this is this whole idea illustrates something that I feel like students should know about the SAT. The SAT rewards the kids who play. The SAT definitely, it doesn't say it in the in their official, corporate newsletter, but they reward creativity, sneakiness, and being willing to pause for a moment before you jump in to use a school method is often rewarded on this test.